Hi, and welcome to this video on how to simplify complex fractions. Before I begin, I'd like to answer a simpler question, and that is, what is a fraction? Let's take a look at this fraction. 1/2. First of all, every fraction is a division problem. That's very important for you to understand. This fraction 1/2 is a division problem. It's the top number divided by the bottom number. And if you enter this on your calculator, you get 0.5. Every fraction is a division problem. If you have one pizza and you divide it among two people, each person gets 0.5 of a pizza. Let's take a look at this fraction. 3/5. This is a division problem. It's 3 divided by 5. And if you put that into your calculator, it's 0.6. If you have 3 pizzas and you want to divide that among 5 people, each person gets 0.6 of a pizza. Okay? So keep that in mind. Every fraction is a division problem. Okay, next thing I want to cover is, how do you divide fractions? Let's take a look. Let's say we have 2/3 divided by 4/5. To divide fractions, you write the first fraction unchanged, change that division into multiplication, and take the reciprocal of the second fraction. So you just flip it upside down. So you turn that division problem into a multiplication problem. And the way you multiply fractions is you multiply the top numbers and you multiply the bottom numbers. Oops. That's not a 12, that's a 4. And on top you get 10, on the bottom 12. And of course that reduces to 5/6. That's how you divide fractions. Now, let's talk about complex fractions. What is a complex fraction? A complex fraction is a fraction inside of a fraction. Let's do an example. Let's take a look at this complex fraction. 2 over 2/3. Keep in mind that this is a division problem. Every fraction is a division problem. And what exactly is that division problem? Well, to know that, you have to find the major fraction line. And that's usually the line that's the longest. See how this line is longer than that line? So the top one is the major fraction line. And what that means is, when you turn this into a division problem, it's the top, the number above the major fraction line, divided by the bottom, the number under the major fraction line. So now we're dividing a whole number, 2, by a fraction. You have to change the 2 into a fraction. And how do you do that? Well, that's easy. You just put it over 1. So it's 2 over 1 divided by 2 over 3. And then, just like above, you change this into multiplication by keeping the first fraction the same and writing the reciprocal of the second fraction. And now you just multiply the top numbers, you get a 6. Multiply the bottom numbers, 1 times 2 is 2. So you get 6 over 2, which reduces to 3. Now I might have pointed out that before we multiplied those two fractions together, because we were multiplying, we could have canceled the 2 on the top of this fraction with the 2 on the bottom of that fraction and gone straight to 3. Okay, so 2 divided by 2/3 is 3. Now, why is that major fraction line important? Suppose we made a mistake and thought that that was a major fraction line. Let's take a look at what the problem would look like then. Then it would be 2 over 2 divided by 3. See how I changed the major fraction line from this top one now to the bottom one. See that? Now let's work this out. Let's work out this division problem. Because remember, every fraction is a division problem. This division problem is the top fraction, and now the top fraction is the one that's above the major fraction line. It's 2 over 2 divided by the number that's on the bottom of the major fraction line. So it's 2 over 2 divided by 3. And again, we're going to change that 3 into a fraction. So it's 2 over 2 divided by 3 over 1. And again, we change that into a multiplication problem by keeping the first fraction the same, changing the division into multiplication, and taking the reciprocal of the second fraction. So we get 2 over 2 times 1 over 3. And then you multiply the top numbers. 2 times 1 is 2. And you multiply the bottom numbers. 2 times 3 is 6. So you get 2 over 6, which reduces to 1 over 3. And again, if you look back here, you could have seen that you could cancel these 2's. And then the problem would be just, this would become a 1. So you'd get 1 times a third, which is a third. Okay, so you notice that on the top problem, this problem here, when we had the major fraction line under the 2, our answer was 3. On the second problem, when we move that major fraction line below the 2 over 2 and just above the 3, we got a different answer. We got 1/3. So it makes a big difference where that major fraction line is. And again, you can usually tell because it's usually the longest line. Okay, so let's take a look at some other examples of simplifying complex fractions. Let's take a look at another problem. 2/3 over 4/5. Okay, obviously this is a complex fraction. This time I've got a fraction on the top of the major fraction line, that's 2/3, and a fraction on the bottom of the major fraction line, 4/5. So again, we interpret this as a division problem, and we write it as a division problem. It's the top fraction divided by the bottom fraction. And again, we change that into a multiplication problem by writing the top fraction, change the division into multiplication, and write the reciprocal of the second fraction. And then we just multiply the fractions. We multiply the top two numbers together. 2 times 5 is 10. And we multiply the bottom numbers together. 3 times 4 is 12. So we get 10 over 12, which reduces to 5 over 6. Now I want to point something out. This trick only works when we have a single fraction on the top and a single fraction on the bottom. If you have two fractions on the top or two fractions on the bottom, you have to combine those into one fraction on the top and one fraction on the bottom before you can write that as a division problem. Let's take a look. Let's try this problem. 2/5 plus 1 over 3/5 plus 2. Okay, so now we've got two terms on the top, 2/5 and a 1, and two terms on the bottom, a 3/5 and a 2. So I need to combine those two terms on the top and the two terms on the bottom. But first I need to rewrite that 1 as a fraction. And I need to rewrite that 2 as a fraction. So that's easy. I just put them over 1. So we get 2/5 plus 1 over 1 over 3/5 plus 2 over 1. Okay. Now to combine the two fractions on the top, I have to get a common denominator for 2/5 and 1 over 1. And it turns out the common denominator is 5. Because I can multiply the top and the bottom of the second fraction by 5. And when I do that, the second fraction becomes 5 over 5. Now both fractions have a 5 on the denominator. 2 over 5 plus 5 over 5. I can do the same on the bottom. The common denominator on the bottom, again, is 5, so I can multiply the second fraction by the top and bottom by 5. And so the denominator becomes 3 over 5 plus 10 over 5. Now I can add the fractions together on the top because they have the same denominator, right? They both have a 5. And I can add the fractions together on the bottom because they both have a 5 in the denominator. And to add the fractions on the top, I'd simply add the numerators. So I get 2 plus 5 over 10, and the same on the bottom. 3 plus 10, whoops, I'm sorry. When I added those fractions on the top, I keep the same denominator, a 5. You do not add the denominators. You only add the numerators. When you add the two fractions on the bottom, you get a 3 plus 10, and in the denominator, you keep the 5. So we get, for the top fraction, we get 7 over 5. On the bottom fraction, 13 over 5. Now we've got a single fraction on the top and a single fraction on the bottom. Now I can write that as a division problem. 7 over 5 divided by 13 over 5. Then I can change that into multiplication by changing the division to multiplication and taking the reciprocal of the second fraction. And you notice, because it's multiplication, I can cancel the 5 on the bottom of the first fraction with the 5 on the top of the second fraction, and I get 7 over 13. Let's do another example. Here's a complex fraction. A squared over 4 over 5 minus 4 over a. Now we got a couple problems here. The top is an a squared. We need to change that into a fraction. Well, that's easy. You just write a squared over 1. The bottom consists of the difference of two fractions. So we need to combine those two fractions, getting a common denominator. And that common denominator is going to be a product of those denominators. So it's going to be 5 times a. Okay, so we got a couple of things we need to change. First, we need to write that a squared on top as a squared over 1 to make it look like a fraction. And then we have to combine those two fractions on the bottom. And they both need to have a common denominator of 5a. So on the first fraction, I can multiply the top and bottom by a. On the second fraction, I can multiply top and bottom by a 5. So when I do this, that a squared on the top becomes a squared over 1. And in the denominator, I get 4a over 5a minus 20 over 5a. Now you notice those two fractions on the denominator both have a denominator of 5a. So I can combine those by subtracting the numerators and keeping the same denominator. So I get 4a minus 20 over 5a. Okay, so now I've got a single fraction on the top and a single fraction on the bottom. Now I can change that into a division problem. It's a squared over 1 divided by 4a minus 20 over 5a. Now, if you're wondering, can I cancel that a with one of those a's? The answer is no, because this is a division sign. And when you're dividing, you cannot cancel from the top of one fraction to the bottom of the other. You can only do that if you're multiplying. So let's change this into a multiplication problem. So we keep the first fraction, change the division into multiplication, and take the reciprocal of the second fraction, which makes that 5a over 4a minus 20. Now we can multiply these two fractions together by multiplying the top of the fractions together. A squared times 5a is 5a to the third, and 1 times 4a minus 20 is 4a minus 20. And we're finished. That's the final answer. Okay, let's do one more example. We have 4 over x minus x divided by 1 minus 2 over x. Okay, so here's a complex fraction. And we need to change the top, that 4x, 4 over x minus x, into a single fraction, and the same with the bottom. To do that, I've got to combine the 4 over x and the x into a single fraction. And the same with the bottom. So first we're going to write that second x is a fraction. And that's easy. We just put it over 1. And the same on the bottom. I'm going to change that 1 into a fraction. Okay, now I can subtract the two fractions on the top if I get common denominators. And the common denominator for the two fractions on the top is x. This first fraction is already over an x. The second fraction, I can multiply top and bottom by x. And the same on the bottom. The common denominator is x. The second fraction, 2 over x, already has an x in the denominator. I can multiply the first fraction, the top and bottom, by x. And then we get this, 4 over x minus x squared over x on the top. On the bottom we get x minus 2 x over x minus 2 over x. Now we can combine the two fractions on the top and bottom because they have the same denominator. On the top we get 4 minus x squared over x. Remember, you subtract the tops, 4 minus x squared, but you keep the same denominator. And the same on the bottom. We get x minus 2 over x. Now we can change this into a division problem. And let's take it to the new line. It's the top, 4 minus x squared over x, divided by x minus 2 over x. And we change that into a multiplication by keeping the first fraction the same, changing the division into multiplication, and taking the reciprocal of the second fraction. Okay, and because we're multiplying, I can cancel this x on the bottom of the first fraction with that x on the top of the second fraction. And I get 4 minus x squared over x minus 2. We can still simplify this a little further, because if you notice that 4 minus x squared can be factored. We can factor that as 2 minus x times 2 plus x. That's a difference of squares over x minus 2. Now, can we cancel this 2 minus x with that x minus 2 on the bottom? No, because they're not identical. But we can modify, or this 2 minus x on the top, we can factor a negative 1 out of that. and write that as -1 times x minus 2. And then we have that 2 plus x over x minus 2. Now we can cancel the x minus 2's. And we're left with a -1 times 2 plus x. Or if we distribute that -1, we get -2 minus x. And that's the final answer. I just want to say one last thing before we finish. We can shorten this process just a little bit, because let's take this complex fraction here. I can write that as a division problem, as the top divided by the bottom, right? And then I would change that division problem into a multiplication problem by keeping the fraction on the top the same and taking the reciprocal of the fraction on the bottom and multiplying them. So rather than write this as a division problem like that, and then changing it into a multiplication problem like that, usually what I do is just skip this middle step and change it into a multiplication problem. I take the top at 3/5 and multiply it times the reciprocal of the bottom, 2/5. That saves you an extra step. And then all you have to do is multiply the numbers on the top and multiply the numbers on the bottom. Saves a little time. Okay, that's it. I hope you learned a little more about simplifying complex fractions.